No, it's fine. I can do the entire screen.
It made 50 of them.
Okay, I want you to keep in mind that it's recording right now. So, okay. So the smallest particle of all living things is an atom. Okay. So we'll do a little bit of review and then go over the stuff that you need to be responsible for understanding in terms of how to use your periodic table to find proton number, neutron number, electron number. So atoms have three main parts called, does anybody remember what the protons, neutrons, and electrons are called collectively, Maggie? Yeah, subatomic particles. So remember, we said the prefix sub means below, like submarine. So these are below the level of the atom. They're the smaller particles that make it up. So within the nucleus, which is the center part of the atom, okay, we have two particles that make up the majority of the mass of the atom, where the weight is. And those are the ones that are not charged. What are the ones that are not charged called? Yeah, what are they called, Aaron? Neutrons, good. And then what are the ones with the positive charge called? Do you remember, Elijah? Protons. Remember proton positive. They both start with a P. And the neutrons are neutral, so no charge. And then the electrons orbit in these electron rings or shells. And typically, the electrons will exist in different distances from the nucleus. So we could, in fact, draw another level out here of electrons. As atoms get bigger and bigger, as their atomic numbers get bigger and bigger, then we would add more and more electrons. Now, remember that we can identify the element based on the number of protons. So there's 2 protons in this nucleus. Who can look off their periodic table and tell me what element this is supposed to be? What do you think, Aaron? Helium. If you look, good job. Helium has got a 2 in that upper left-hand corner, so that means 2 protons in the nucleus. So this is, in fact, a diagram of helium. Okay, so we're looking at that atomic number to determine the type of element. Okay, so remember I gave you this analogy about ice cream flavors and ice cream scoops in relation to elements and atoms to help you understand the relationship between the two. So imagine going to an ice cream store. Let's say they have 30 different flavors of ice cream. Those are the elements. So the ice cream flavors represent the elements on the periodic table, the things I have available from which to build my dessert. The smallest amount of ice cream the store will sell me is a scoop. That's like your atom. So all the elements on the periodic table are like all the different flavors of ice cream. The smallest part of an element is the atom. So the atom is like the scoop is to the ice cream, okay, ice cream flavor. So blank are the simplest of all chemical substances. The elements are the simplest of all chemical substances and cannot be broken down using ordinary chemical means. So if we do an explosion, some type of chemical reaction, atoms themselves are going to stay intact. The protons and neutrons aren't going to go flying out of the nucleus. Okay? There are 92 naturally occurring elements that are listed on the periodic table. So remember, we discussed the periodic table. Everything after 92, which is uranium, is man-made, where they've used particle accelerators and bombarded the nucleus of an atom to create bigger and bigger atoms. But a lot of those are radioactive. They're unstable. They break down. The nucleus decays, and that happens very, very quickly. Okay, so each element is made up of only one type of atom. For example, if I have a huge chunk of the element gold, it is only made up of gold atoms. Okay, this is like the smallest unit of flavor sold by the ice cream store, the scoop of ice cream. The whole container of ice cream of a particular flavor is like the element. One scoop of the ice cream flavor is like one atom of the element. So important vocabulary to make sure that you're understanding. And you guys completed an assignment where you filled in different definitions, you need to make sure that you know those definitions and that you can use your periodic table to identify these different things. So the first one is the atomic number, okay? The atomic number, and I'm going to abbreviate that like that, is the top in an element box. It tells the number of protons found in one atom of the element. This number never changes, okay? Regardless of whether that atom chemically reacts and forms a compound, that number that's in the nucleus of the atom of the protons never changes. That's why we can define the type of element based on the proton number. Electron and neutron numbers can change. Proton numbers cannot. So right up here, 29 is our atomic number. That means if I'm a copper atom, I have 29 protons in my nucleus, okay? So given the atomic number, you should be able to identify the element. For example, will you look at your periodic table and tell me the element that has an atomic number of 7? What is it, Brian?
Nitrogen.
It is nitrogen. If everyone looks at the periodic table, there's a 7 up there. That's the number of protons, and that tells me that it's nitrogen. Okay, what about 15? Who can tell me what element has 15 protons in the nucleus? Bella? Okay, what's the symbol? P. So it's phosphorus. Okay, so it's right here. 15P is phosphorus. So you pronounce that PH with an F sound. Okay, so good. So we know now that the atomic number is that number at the top of the box, and that's going to tell us the number of protons. Okay, is everybody good? Can I flip the page?
Yeah.
Okay. So now we're going to look at atomic mass. Atomic mass is this bottom number, and this is going to tell you the weight of the atom. And it's basically the number of protons plus the number of neutrons. But remember, it's a decimal because it's an average weight of the atom, given that there can be different forms of the same element with different numbers of neutrons. Okay, so the atomic mass, and this is a really good reference sheet. Hold on to these notes because they'll really help you in terms of if you get confused on your homework, look back and it'll help you understand what to do to figure out the protons, neutrons, and electrons using your periodic table. So the atomic mass is a number that gives you the average weight or mass of the atom. It's usually a decimal number and found in the bottom of the element box. It may vary slightly from one book or resource to another. That's why I told you, don't pull a periodic table off the internet. Use the ones I give you so that our answers are consistent and there's no confusion when I'm checking papers, okay? So it is found, the atomic number is found by adding the number of protons and neutrons together, okay? Because remember, the weight of one proton is 1 atomic mass unit, those specialized small units that we use to measure how much an atom weighs. Very, very tiny number. What did we say it was? 1 atomic mass unit is like 1.67 times 10 to the negative 24 grams. So it's 0.23 zeros followed by a 167. Very, very tiny. That's why we use the atomic mass unit. Okay, and a neutron weighs the same. Electrons are so tiny, they don't really weigh much. We don't calculate them into how much the atom weighs. So when we add these together, we get the mass. So you might be wondering why it's a decimal number, okay? The reason textbooks have the atomic mass listed as a decimal number is because it's an average, and actually it's a weighted average depending on how much of each form of that element is found in nature, okay? Different forms of each type of element exist. These different forms have different numbers of neutrons and are called isotopes of the element. So think of if you had to memorize one word to go with the vocabulary term isotope, think form. different forms of the element, of the same element. So these right here, carbon 12, carbon 13, carbon 14, the 12, 13, and 14 is telling you the mass of a specific isotope of carbon. So these are isotopes. So look on your periodic table and tell me for carbon 12, how many protons does carbon 12 have? How many protons? Can you find carbon? It's in the upper right. What is it, Preston? It has 6 protons. That's what our periodic table tells us. So it's going to have 6 no matter what. Doesn't matter if I'm carbon 12, carbon 13, or carbon 14. The number of protons can never change. When you add the protons and neutrons together, that gives you how much it weighs. So if it weighs 12 and we have 6 protons, how many neutrons would we have, Lakin? 6, because 6 plus 6 equals 12. And when we add the protons and the neutrons, we get the mass. Okay? So then, Lakin, how many neutrons for carbon 13? 7. 6 plus 7 is 13. And then how many neutrons would we have for carbon 14, Lakin? 8. Good. Okay? So the mass of an atom is measured in special tiny units called atomic mass units. And just as I said before, it's such a small amount in terms of grams that we've come up with our own specialized units for measuring how much an atom weighs. Okay? This is such a tiny number, it's easier to say AMU or use AMU. To find the weight of an atom, add the proton and neutron numbers together. This works because each proton weighs 1 and each neutron weighs 1. The mass of an electron is so tiny, we don't calculate it into the actual weight. So how can you use your periodic table to find your neutrons? Well, let me just kind of draw a picture right here real quickly for you. So let's pick an element. Let's do beryllium. Beryllium's got a 4 right here, and it's got a 9.012. Okay, so let's write this down on our sheet. And I added something to it. Let's write, this is a box off the periodic table for the element beryllium. This is the atomic number. It's the number of protons. And if the atom is neutral, has no charge, it's going to be the number of electrons as well. Okay, so that atomic number is going to give us our protons and our electrons. Then this part right here is going to give us our protons plus our neutrons. So what you're going to do to find out all of your particles is you're going, well, actually, we know our protons and electrons are 4. To find our neutrons, what we're going to do is we're going to take that bottom number, your atomic mass. Okay, so this is our atomic mass. This is our atomic number up here. We're going to take the mass and subtract the number to find the number of neutrons. So let me just explain why this works. The mass is the protons plus the neutrons, okay? And the number is just the protons. So if we have protons and neutrons together and we take away the protons, we're going to be left with the neutrons. So you will have to round the mass when you use your periodic table to the closest whole number. So 9.012, is that closer to 9 or 10? 9. Remember, we go to the tenths place. If it's 5 or above, we round up. If it's below 5, we leave it the same. So it's a 0, so this is going to be 9. We subtract 4, and that's going to give us 5 neutrons. So if I'm beryllium, I have 4 protons, 4 electrons, assuming that I'm neutral, okay? And I'm going to have 5 neutrons. Okay, so that's basically how you do it. You probably, if you didn't write this down, should write that down because that will be very helpful on your homework today. Okay, so Carmen, I'm talking to you. Write that down, okay? So let's go ahead and label this stuff so we can decipher what's in each box on our periodic table. So remember, this number at the top, we're going to call our atomic number. And it's the number of protons. But if the atom is neutral, which it'll be always unless I tell you differently, it's going to give us our number of electrons too. Because when positives and negatives are equal, they cancel each other out and the atom has no charge. Then this right here is going to tell you the number of electrons per ring. So what this is telling us is in the first ring closest to the nucleus, there's 2 electrons. In the second ring, there's 3. Make sure you're taking notes on this, okay? Write it down. That's why we're supposed to label it. This will be a tool for you to help you do your homework. So if we were going to draw a boron atom, we would put 1, 2, 3, 4, 5 atoms in the nucleus, okay? Now I want to do the neutrons before I do the electron rings. And again, I would copy this down. So James, make sure you're copying it down. So 10.8, this is the atomic mass. And this is going to tell us our protons plus our neutrons, okay? Because every proton weighs 1, every neutron weighs 1. So we're going to take our atomic mass and round it to the nearest whole number. 10.8 would be 11, right? And we got the protons and the neutrons, and we're going to subtract our protons, which is 5. So that means your average boron atom has 6 neutrons. You with me? Make sense? Okay. So then let's go ahead and we'll just draw circles right now. 2, 3, 4, 5, 6. This is how we would draw our atom. Okay, so these are our neutrons. And then the periodic table tells us we have 2 electrons in the first, 3 electrons in the second ring. So I'm going to go ahead and draw the first ring closest to the nucleus, and I'll represent my electrons like this. Okay, I'm kind of putting them on the outside of it because if I put it on the circle, it'll look like a plus sign, right? So I've got 2 negatives in the first ring, and in the second ring, I have 3. So this is how I would draw that atom. So one of your objectives is to be able to build or draw models of atoms using your periodic table. So you have to know how to interpret the information on your table. You don't memorize your table, you just know how to use it. Okay? So we did our proton, our neutron, and our electron. We said the proton is 5, and if you want to, you can call it plus 5. The electron is minus 5. They cancel each other out. And then the neutron number for your average boron atom, even though you can have different forms, different isotopes, is about 6 neutrons. Okay? There can be multiple different forms of the same element with different numbers of neutrons. Okay? And remember, I'll post your filled in notes on the internet too, in Google Classroom if you're having trouble seeing or getting any of the information. Okay? So flip it to the next page when you're done, and we're going to do some practice. Okay? I'm going to do the first one with you, and then I'm going to have you guys try some. Okay? Can I flip? Okay. All right. So this right here, let's label everything on this page. So this is our protons. It's also going to equal our electrons because we're going to assume everything is neutral, has no charge. These are the electrons per ring. Okay, and I want you to notice if you add these up, they should equal this. 2 in the first ring plus 8 in the second ring is 10. Plus 2 in the third ring is 12. 12 electrons is what we said. And then this right here is our protons plus our neutrons. Okay, that's how much the atom weighs. So how many protons in magnesium? We said it's 12. And I'm going to go ahead and put a plus there just so you know it's protons. And then I'm going to skip down and do the electrons next. This is asking me how many in each ring. So in this periodic table, it lists out how many in each ring. So we've got like this. So we're looking in this upper right-hand corner. And remember, if we add those rings together, that's going to equal a negative 12. The positive protons cancel out the negative electrons. And then our neutrons, remember, we're going to take the atomic mass, which is protons plus neutrons, the bottom number, okay? And we're going to subtract the top number, which is the atomic number. And the reason that works is the mass is protons and neutrons. We're taking away the protons, and that's going to give us the neutrons, okay? So we're going to round 24.3. Grayson, is that closer to 24 or 25? 24. So we're going to take 24, we're going to subtract 12, and that's going to give us 12 in terms of the number of neutrons. Okay, what I want you guys to do is right now try to fill out the rest of this sheet, and then we're going to go over it together. Keep going, try your best. Same thing, but it's asking you to draw it then. If you just want to fill this out, I can show you what to do for the drawing. Don't let that last one fool you. Just go ahead and try to fill out the blanks. And then if you're a little confused about the drawing, leave the drawing be. So try to do the last one. The middle part is, remember where your protons and neutrons are. That's the nucleus. And then you got the electron rings. Yeah, the first ring is the one closest to the nucleus, closest to the center. So work from in out. Then you take this around it and subtract the top to get the neutrons. Okay? So 18.9 is like 19, and then subtract 9. Remember that you always have the availability of a calculator. You can always use the calculator. Okay? Let's go ahead and start to go through some of these. Okay, we want to find out protons, neutrons, electrons for fluorine. Okay, so Braden, how many protons does fluorine have? It has 9 right here. So we're going to go ahead and put that in the blank. What do we do, Caden, to find the number of neutrons? Right. So which number is protons plus neutrons? Nope, that's the protons. So this is the protons and neutrons. Okay. So maybe label that if you guys don't have that or if you're confused still. So now what are we going to do with this number, Caden, the 18.9? What do we have to do with it before we subtract? Do we deal with it as a decimal? No, so what do we do? Round it. Yep. Is it closer to 18 or 19? 19. And then we subtract the protons, so that's going to tell us that your average fluorine atom has 10 neutrons. Okay, Aaron, how many electrons are in the first ring? 2. That tells us right here are electrons. Okay, so we've got 2 in the first ring, and then how many in the second? 7. Notice that 2 plus 7 equals -9, so it's a neutral atom. The positives and negatives cancel each other. Okay, Carmen, how about you on the next one? So what is this number going to tell us up here? Right, and what is this number going to tell us down here? Very good. And then what is this going to tell us here? Yeah, number of electrons in each ring. Okay, so Carmen, how many protons does an arsenic atom have? 33. And then what do I do to find out my neutrons? Right, the atomic mass, which would round to what? Good, 75. And then what do we do? Yeah, so we take the atomic number on the top. It really does help to have that vocabulary, okay? So that's going to be 42. So the average arsenic atom has 42 neutrons, okay? That's the average. All right, looks like I got to plug in here. Okay, so now how many in the first ring? We've got our 2. How many in the second ring? 8. 18 in the third ring, and 5 in the fourth ring. And if we were to add those together, 2 plus 8 is 10, plus 18 is 28, plus 5 is 33. So that's going to add up to 33 electrons. So again, the protons and the electrons equal each other. All right, let's do our last one. If we look at the periodic table, nitrogen is going to have our 7 protons, okay? So it's going to have 7 protons. If we look at the periodic table and we find this protons and neutrons, it's 14.007. So that rounds to 14. And we're going to subtract off the protons. So the average nitrogen atom will have 7 neutrons. And then the electrons we're going to have is going to be 7. And it tells us in this chart that 2 go in the first ring, 5 go in the second ring. Okay? So for my electrons, I might want to write 2, 5, so I know how to draw my atom. The atomic number, remember, is the number of protons, so that's 7. And the mass number, that's just asking you when you get an exact number, that's the protons plus the neutrons, so that's going to be 14. Okay? So then when we go to draw it, we want to put, and this is hard, I think this is a little small, but we want to put, I don't think I'm going to draw out the protons and neutrons because it's too tiny. So I'm going to put plus 7 for my 7 protons, and then I'm going to put maybe 7N for my neutrons, okay? In this particular diagram, it's really hard to draw in that little nucleus. So I'm just going to label my 7 protons, 7 neutrons. Then I'm going to put 2 electrons in the first energy ring, closest to the nucleus. And in the second one, I'm going to put 5. 1, 2, 3, 4, 5. Okay. I'm going to have you guys get started